Hi, so we're going to go through the cardiac cycle. I'm going to try and get it done in 15 minutes. So we need to look at an ECG of one cardiac cycle, coordination of the heartbeat, stages in the cardiac cycle, and the opening and closing of the valves, and then link them all together. So we've got 4 valves in the heart. We've got mitral, aortic, pulmonary, and tricuspid. So in order from left to right, we can use a little acronym MAPT, mitral, aortic, pulmonary, tricuspid. The pulmonary goes between the right ventricle and the pulmonary artery. The aortic goes between the left ventricle and the aorta. The tricuspid goes between the right atria and the right ventricle, and the mitral goes between the left atria and the left ventricle. Okay, the 2 atrioventricular valves, so that just means between a atria and ventricle. We've got our tricuspid and we've got our mitral. And atrioventricular we're going to call AV valves for short. Semilunar valves go between a chamber and outside the heart, so that includes our aortic and our pulmonary. So how do the heart valves open and how do they close? So they open when the pressure in the chamber behind the valve is more than the pressure in the chamber in front of the valve. So if I have my right atria and my right ventricle, if my right ventricle has high pressure, my right atria have high pressure and my right ventricle has low pressure, that will cause the valve to open. It closes when the opposite happens, so the pressure in front of the valve is more than the pressure behind the valve. So this is the cardiac cycle. Sorry, this is how the heartbeat is coordinated in 4 steps. So first of all, in your right atrial node, you have some tissue called the Cyanoatrial Node. Now, the heart is special because it's myogenic, and that means it can generate its own electrical impulses or action potentials without stimulus from the central nervous system. So the cyanoatrial node sends out an electrical impulse, and that causes our right atrium and our left atrium to contract simultaneously. And we see this on our ECG here as this first bump, also known as a P wave. Now, the electrical impulse travels down to a piece of tissue called the Atrioventricular Node. Now, it's made of a non-conducting material, so it actually slows down here. It takes about 0.1 seconds to get across this Atrioventricular Node, and that is because we need time for the blood to move into our ventricles. It then goes through tissues in our medium septum, called the bundle of His, which are special muscle fibers, and then these branch out into other muscle fibers called the Purkinje tissue. The impulse will then travel to our ventricular wall muscle, and when that contracts, our left and right contract at the same time, and this is this big wave here. So that is QRS, and what we call this is our QRS complex. Okay, so in a nutshell, the electrical impulse, also known as an action potential, or you could say depolarization, goes from our SAN to our atrial wall muscle, through the AVN, through the bundle of His in the median septum, out through the Purkinje fibers, and eventually we get our ventricle wall muscle contracting. So this is the cardiac cycle. Consists of 3 stages, but it's a cycle. So it continues, and it's the movement of blood through the heart and out of the heart in one heartbeat. So there's 2 terms we need to know here. So systole, that's when your muscle contracts. Diastole, muscle relaxes. So when you die, you're very relaxed, so you can remember diastole. All right, so in stage 1, our atria contract. Now, our LV valves are already open from stage 3, but when they contract, it increases the pressure in the atria, and that forces blood into the ventricles. Forces blood into the ventricles. And so ventricular pressure will actually increase a bit. Now then, in stage 2, our ventricles contract. Now our ventricular pressure is higher, and our atria pressure is lower. So our LV valves will close. And our heartbeat sound goes lubbed up. So this, when the atria closed, when the AV valve closed, that's our lub sound. Now that we've got higher pressure in our ventricles than in our blood vessels outside, so we've got lower pressure in our aorta and lower in our pulmonary artery, our semilunar valves will open as well. And when this happens, the blood is forced out of the heart through the aorta and the pulmonary artery. On stage 3, both the ventricles and the atria relax, which is diastole. Now, pressure in our ventricles is lower than atrial, or pressure outside. Here we go, lower, higher. So our semilunar valves will shut, these ones and these ones. When these shut, it causes the dup sound of the heartbeat. Because there's higher pressure in the atria, the LV valves open, and blood will move into the atria from the pulmonary vein and through the vena cava. Now, the LV valves are open, so blood will naturally move in from your atria to your ventricles, and this is just passively down a pressure gradient. This occurs until the volume of blood in both the atria and the ventricle increases, and then the cardiac cycle will happen again to force the blood through the chambers and then out the heart. All right, if your valves are not, if your heart chambers aren't full before this happens, when they contract, you've got no blood to force out. So the stage 3 is our passive filling of all the blood chambers. So here is our cardiac cycle graph. Stage 1 here, atrial systole. Stage 2, ventricle systole. And stage 3, ventricular diastole, which goes on to here. And you'll notice that the pressure of our atria and ventricles is 0, apart from in stage 1, when our atrial pressure goes up, and then because blood moves into the ventricles, ventricular pressure goes up a bit. Then in stage 2, our ventricular pressure goes right up here. Atria stays basically the same. Then they both relax and the pressure goes down to 0. Okay, so in a nutshell, if we were to join these things together, in order for stage 1 to happen, the cyanoatrial node must send the electrical impulse. stage 1 happens. And then in order for stage 2 to happen, that electrical impulse needs to go through our ABN, through the bundle of His and the Purkinje fibers, and then stage 2 will happen. Following that, stage 3 will happen, and we'll return back for another cardiac cycle. Okay, so a bit of a summary. So before stage 1, our alveoli valves are open. In stage 1, our atria contract and our ventricles relax. Then in stage 2, our ventricles contract and our atria relax, our alveoli valves close and our semilunar valves open. Then in stage 3, both our atria and ventricles relax, the semilunar valves close and the AV valves open, and they are continued to be open before stage 1. Okay.